think the disappearance, or at least the drop in significance of the great Chinese assemblages of men and machinery to make weapons and to equip the army, that process is obviously political. The decision that you can establish a secure, centrally managed imperial bureaucracy in which the military is going to be used to secure the internal order of the state and then defend it at its most distant boundaries, begins completely to change the role that this large-scale military industry plays. So whereas in the West, most cities foster and sponsor military engineering and development, what we see in China instead, I think, is, if you like, the rarefaction of military science and technology, in which it's brought together in a very few places, and then the rapid development of technical change, technical design is simply brought to a halt. And that's really a major contrast between Eastern and Western solutions to the problem of military administration. Beyond that, both in China and in Japan, for example, from the 1500s onwards, these are regimes which are absolutely aware of Western military significance. The adoption of guns in Japan, for example, in the 1500s, is very much in response to and in dialogue with what's happening in the West. However, in the great modernization of Chinese and Japanese society during the 19th century, what we have to understand is that the initial and principal motive for that modernization is the obvious superiority of Western military strength. Until, what, 1600, the East and West are really on a par, and it would have been hard to distinguish who was more militarily stronger. But when, in the early 19th century, European navies and armies begin to destroy, and destroy relatively effortlessly, Chinese military force, it becomes extremely apparent that at least Western military technique needs to be adopted. So in China, for example, Western military techniques and resources are used precisely in order to re-establish internal order against the major, massive peasant revolts against the empire in the 1860s to the 1880s. And similarly in Japan from the 1860s, it's Western military resources that really look like the reason to modernize. The question, however, is, can you adopt Western military technology without Westernizing? By and large, the Chinese administrators thought you could. You could simply buy in, adopt, and then use Western military techniques to pacify the empire without any need whatsoever to Westernize the social and political system. Japan takes a completely different path. From the 1860s onwards, Japan understands well that the Western military system is integrally linked to Western social relations and Western economic arrangements. And so we see the Westernization of Japan taking place partly because they well understand that if you want Western military might, you have to have a Western-style society. Really intimate relationship between the bringing together in the big Western arsenals of a whole series of different skills and personnel and material resources, metal, wood, powder, and so on, and the development of rational understanding and reliable knowledge, which is then deliberately and pretty quickly fed back into the improvement of these military delivery systems. Artillery is a really good example of this. So the first major works on gunnery and ballistics, which are written in northern Italy in the 1500s and early 1600s, are also classics of the Western scientific revolution. And they really do have major effects on the efficiency of Western artillery. By the 18th century, this alliance between theoretical analysis and practical control is really pretty close. So in London and Berlin and Paris and St. Petersburg, expert mathematically trained analysts, many of them working at the arsenals or the gun factories or the testing ranges of the big Western armies, are producing detailed mathematical analysis, not just of the paths of cannonballs, but also of the best design for guns. They build new testing rooms, genuine laboratories, where, for example, the speed of bullets and cannonballs can be measured, where the best kind of projectiles can be tested. And it's that constant conversation backwards and forwards between quantification, precision testing, and then embodying the knowledge and skills that you've achieved through these tests in rather elegant and subtle instruments which can be given to soldiers on the battlefield so that their decisions can be automated and mechanized. It's that system that I think holds the key to Western military advance. Very good examples of this, for example, are the widespread military tables that are printed from the 17th and 18th centuries onwards, which allow gunners to know how to range their guns to achieve maximum delivery power or maximum distance across which they can shoot, or the rather precise instruments which are used to make sure that just the right kind of cannonball is being put into just the right kind of gun barrel. The windage, which is the gap between the ball and the barrel, is a very sensitive parameter, and highly precise instruments are then given to artillerymen so that instead of having to make complicated decisions on the battlefield, they can make automated decisions on the battlefield. It's that relationship between precision measurement and standardization on the one hand, and building skills back into those instruments, so that, if you like, free will is no longer a problem when you're fighting. That turns out to be the guts of the military revolution of the 18th and 19th century. So, center stage in military technology, certainly from the 1600s onwards, is the ability to turn metal precisely, reliably, and in the same way over and over again. And that meant building lathes, turning machines, vices and jigs, which could hold carefully worked pieces of metal absolutely stable, and then be used to reproduce a particular design in hundreds, if not thousands of examples. You see that in the case of guns, and then rifled guns, or cannons, and then cannons which are bored from the solid. Now those lathes, the big new machine tools of the 17 and early 1800s, are absolutely fundamental elements in the automation and industrialization of those years. And they start out as military systems for the Navy, for example, or for the artillery. Once these big, powerful machine tools have been designed, however, they can then be turned to a host of other uses. So, for example, the power tools, the machine tools, which were used to make standardized parts for guns, were quickly turned into machine tools that made standardized parts for railways, for steam engines, for cotton machinery, and eventually for a host of other devices. It's not a coincidence that the major American gun manufacturers start building typewriting machines by the end of the 19th century. That ability to build identical, complicated bits of machinery with replaceable parts, which itself relies on the military systems of lathe engineering and power tools, that then starts to industrialize the whole of the Western economy. The fact that in most Western European cities you now had concentrations of workshops and very skilled workers using power lathes and machine tools to build very large numbers of identical and reliably performing devices meant that you suddenly had the resources to mechanize very large parts of the consumer economy too. So that, for example, it's exactly in the areas where the big arsenals are that you see these machine tools being built, and then it's in exactly those places that Products are made for the new railway industry, in steam engines, in the cotton trades and weaving. They come straight out of military hardware expertise and from these tools. It's not a coincidence, for example, that gun manufacturers by the end of the 19th century turned to make typewriting machines, and the first calculating engines built in London in the early 19th century are made by men who up till then had been working for the army, making standardized parts for guns. So right across the consumer economy at the moment of industrialization in the West, it's very often military systems using high-powered machine tools that then start to take over the automation of the rest of the economy. The ability to make pretty cheap but extremely reliable objects using these new systems of automated production and standardized parts has extraordinary effects right across society. A very good example is the humble button. Buttons matter if you're cold. You can't keep warm that easily unless you're able to button up your clothes. Buttons are a Western invention. The East lacked them. And the ability to make cheap buttons, and then cheap metal buttons in places like Birmingham by pouring metal into casts and then making very large numbers of these identical items cheaply for clothing for a very large section of society. That was actually a key development of the Industrial Revolution. And some of the leaders of the Industrial Revolution in cities like Birmingham make their money making buttons. The Japanese don't have buttons at this stage. Instead, they tie their clothes together. One of the things the West brings is this amazing technique for attaching one piece of cloth to another. And the Japanese word for button comes from, in fact, the Portuguese word for button. And it's a really good example, I think, of how even extremely mundane, but actually quite important aspects of our everyday life depend on bringing together large-scale markets, moving beyond the luxury good market to really mass consumption, and how that actually does depend on metal trades and on the ability to make standardized goods in very large numbers so they're cheap. Steam engine is really a kind of pump. It has a cylinder, it has a piston which is pushed up and then brought down the cylinder, and that's going to be attached to a device to draw water out of the mine. Think of a cannon as a one-shot pump. The ball is a piston which is driven up the cylinder by some kind of explosion or expansion immediately behind it. But unlike the pistons which work up and down in steam engines driving pumps, a cannon is a one-shot pump. The piston goes up the barrel and never comes back. But in every other respect, it's extremely similar. And the ability to build standardized pumps and standardized tubes was absolutely decisive for the construction of steam engines. What it meant was that if you could bore constant diameter tubes which didn't blow up when you let off some charge behind the piston, and which had a constant bore all the way along, and which got the gap between the piston and the tube just right, not too tight, in which case the thing would explode or warp, and not too loose, in which case you were losing an enormous amount of the energy from the expanding steam or the explosion. All that technology is weapons technology, and without the ability to bore cannon tubes straight, true, and reliably, you could not make the kind of steam engine that we see in 18th century England.